Good afternoon, class. We are looking at exam 2 review, chapter 3, differentiation rules, covering from 3.1 to 3.8. And here's section 3.4, the chain rule, and 3.5, the implicit differentiation. So we're going to continue. Here's the example. We want to look at y equals sine squared of 8x. Just to make sure we know what we are dealing with, we're going to rewrite it as sine of 8x to the second power. This way we know that we have to use the extended power rule. So we start with 2, then sine 8x to the power of 1, or simply sine 8x. And then the derivative of sine 8x. Now remember, sine, the derivative is cosine, which means cosine of the same argument, cosine 8x. By the chain rule again, we need the derivative of 8x, which is simply 8. And now we put everything together, we get 16 sine 8x cosine 8x. By the way, 2 of them is sine of 16x, the double angle, and this becomes 8, just in case. All right, what about this one? F of x is 3x times 3 to the power of x. So we notice this is the product of f and g. We need to use the product rule on that. So first we need f prime, which is 3, times g, which is 3 to the power of x. Now we need g prime. What is g prime? Any exponential, the answer is itself. Since the base is not ln 3, okay, so I'm looking at this, right? And of course, f is 3x, so times 3x. And I'm going to put an asterisk next to it again, just to let you know this is it as far as calculus is concerned. However, this is not a finished job, and we have to finish it. I can't emphasize this enough. To do so, I'm going to put a 1 here so you can see that according to the product rule for the exponentials is 3 to the power of 1 plus x, or x plus 1. Same thing for this one. So we are going to write the first one as 3 to the power of x plus 1. The second piece, 3 to the power of x plus 1, and then times ln 3 times x. Therefore, we can clearly see that the common factor of 3 to the power of x plus 1 can come out and be factored. This leaves us 1. This leaves us the product of these two, and we write it as x ln 3. That's how we write it. All right. Observations show that the length in millimeters from nose to tail of a Siberian tiger can be estimated by the function L equals 0.25 W to the power of 2.6, where W is the weight of the tiger in kilograms. Furthermore, the young tiger's weight can be estimated in terms of its age 10 days by the function W equals 3 plus 0.21 t. How long is the tiger? When it's 100 days. Okay, so what we are going to do is to solve this actually 2 ways, and sometimes one is easier than the other. That's what we want to remember, all of them. So having said that, just the way it is, this is elementary algebra we're going to plug in. So if I plug in 100 here, 0.21 has two decimals, 100 has two zeros. They cancel each other. The product is simply 21. Plus 3 is 24 kilograms. Now, when it's 100 days old, that's the weight. What is the length? Plug it in. So L of 24 is 0.25 times 24 to the power of 2.6. And you do the math, and it gives you 969.369, close to 1,000. Remember, 1,000 millimeters is about 1 meter. And that's elementary algebra breakdown. However, this part, at what rate is the length increasing when it's 100 days old? This is calculus. So just the way it is, we're going to go with the Leibniz's notation. dy dt is dy du du dt. So we want, in this case, dl dt. So we're going to write it in this fashion, meaning from L to T, the intermediate variable, what is it? W. So dl dw dw dt. And to differentiate this with respect to W, we say 0.25 times 2.6 W to the power of 1.6. To differentiate dw dt, to differentiate W with respect to T, you just get 0.21. The product of the three numbers gives us 0.1365 W to the power of 1.6. Now, if we were to write this as a function of T, then you have to replace the W with 3 plus 0.21T. They didn't. They just want to know what's the rate when it's 100 days old. Well, when it's 100 days old, that's the weight, so you can replace it right here. So 24 from the previous part. You raise this to the power of 1.6 times 0.1365, and it results in 22.0532 units of length over units of time, millimeters per day. However, this is easy enough. We can find the composite function. What would be, here's the second method. L of T replace the W, and you get L equals 0.25, parentheses 3 plus 0.21T to the power of 2.6. Now, of course, if I plug in 100 here, and evaluate it, I must and I will get the same answer that I got here for the length, everybody. So that's pretty straightforward. Now, what about the LDT or L prime of T? Well, we're going to differentiate this using the extended power rule. 0.25 times 2.6, the parenthesis to the power of 1.6. Now, the derivative of the inside by the chain rule or extended power rule, 0.21. So one more time, 0.25 remains, times the exponent 2.6. Then the parenthesis to the power of 2.6 minus 1, which is 1.6. Now, the chain rule says times the derivative of the inside. Again, the three numbers result in this, 0.1365. And notice, these two parts are identical. If we had replaced the W, we would have got exactly the same answer. And now, of course, if you plug in 100, it is supposed to give you the same answer. What is the point? We can use the composite function, and it's easy enough that can be used. We can also use Leibniz's notation. In some instances, it's a lot more difficult to find the composite function, so you should be familiar with Leibniz's methodology as well. The amount of glass recycled in a community is G of P equals the square root of 0.5 P squared plus 7 tons, where P is the population in thousands. It is estimated that T years from now, the population of the community will be P of T equals 4.4 plus 0.1 T squared thousands. How many tons of glass are expected to be recycled 4 years from now? So having said that, again, elementary algebra. So if you replace the T with 4 right here, 16 times 0.1 is 1.6 plus 4.4 is 6,000 people. Replace it here to find the amount of glass. 6 squared, 36. Half of it is 18. Plus 7 is 25. Take a root and you get 5 tons of glass. So this is elementary algebra. Now calculus. Find the rate at which the amount of glass recycled is changing with respect to time 4 years from now. And of course, we want dg dt, the amount of glass per unit of time, dg dt. In general applications, we must include units. So that is, in Leibniz's notation, what should we write? dg dt here. So again, look at dy dt, dy du, du dt. So from g to t, the intermediate variable is p. Therefore, dg dp, dp dt. So we are going to differentiate this dg dp. To do so, we're going to raise it to the power of 1/2 to get it ready for the extended power rule. So 0.5 p squared plus 7 to the power of 1/2. So to differentiate this, we get 1/2 times 0.5 p squared plus 7 to the power of 1/2 minus 1, which is negative 1/2. And times the derivative of the inside, which is 0.5 times 2p. So let's look at it here one more time. 1/2, the parenthesis to the power of 1/2 minus 1, which is negative 1/2. Now the derivative of the inside is just p, or you might say 0.5 times 2p. So that's dg dp. What about dp dt? This one is simply 0.1 times 2t, which makes it 0.2t. Now, we are going to simplify this, and then we're going to plug it. First, we're going to simplify. I'm going to start with this. We see a fraction, 1 at top, 2 at the bottom. We see this one at top with negative 1/2 as the exponent. This goes down, becomes positive 1/2. And positive 1/2 means square root. In other words, next to 2, put this one. 0.5 and 2 cancel each other. They become 1. So we have a p at top, 0.2 at top, and t at top. Now, I'm not going to replace the p because I already know when t is 4, p from the part A is 6. So again, first of all, understand this is the same as the denominator here, everybody. Look at these two are the same. These two cancel each other. We get p times 0.2t. And t is 4. When t is 4, we know p is 6. Now we are ready to plug it. When we plug in, the top becomes 0.2 times 6 times 4. But look at the bottom. Square root of 0.5 p squared plus 7. That's exactly what it is. Square root of 0.5 p squared plus 7. When p is 6, we know it's 5. So I really don't have to do the work. I just use the fact that I got 5 here. So the bottom is 10. The top is 4 times 6 times 0.2, 4.8. Divided by 10 is 0.48. Units of G over units of T, tons of glass per year. And we are done. Which means 4 years from now, the amount of glass recycled is increasing at the rate of 0.48 tons of glass per year. That's the meaning of it. Now, This is an example I don't want to do by a composite function. If I were to do that, I would replace the p with this, and I'm going to get g of t is the square root of 0.5, parentheses 4.4, plus 0.1 t squared to second power, plus 7. And this is a lot more difficult to differentiate. The first part is not a big deal. It's elementary algebra. So that's why we learn both ways. All right. Implicit differentiation. Functions expressed by one variable are defined explicitly in terms of another variable. For example, y equals x squared minus 2x plus 1, or in general, y equals f of x. Some functions are defined implicitly by a relation between x and y, such as x squared plus y squared equals 25, or x cubed plus y cubed equals 6xy. In some cases, it is possible to solve such an equation for y, and in some cases, it is not easy or even impossible to do so. In such cases, we can use the method of implicit differentiation. This consists of differentiating both sides of the equation with respect to x and then solving the resulting equation for y prime or dy dx. By the way, when we say with respect to x, if x is the independent variable. So in short, not necessarily x, but rather independent variable, whatever it might be. We're going to start with a very easy example that can be done both ways. So we're going to differentiate 4x plus 2y equals 10 two ways. Explicitly means solve for y. So let's solve for y that by moving 4x to solve for y, we're going to divide by 2. Y becomes negative 2x plus 5, and everybody knows y prime or dy dx is negative 2. Now, very straightforward. It's easy to solve for y, but remember, what if we don't want to solve for y, or if we can't solve for y? So let's start with what is given. So for x, the derivative is 4. What about 2y? It's important to know d dx of y is y prime or dy dx. It's just imagine, and literally, if it helps, just change it with g of x. The derivative of g of x is g prime of x. So 4 plus 2, either write y prime or dy dx. 10 is a number, any number, the derivative is 0. And on purpose, I'm writing dy dx because I want to again mention and show you that they're the same. So I'm going to move the 4 becomes negative. I'm going to divide by 2, and dy dx, just as we found it here, or y prime is equal to negative 2. In other words, we showed for an example that we can solve for y explicitly, the derivative is negative 2. Also, the one that we don't want it to, it's the same answer. So implicit differentiation works as well. Given the circle x squared plus y squared is 25, find y prime. Reminding you of a couple of things. Remember, an equation of a circle is x squared plus y squared equals r squared if it's centered at 0, 0. If it's centered at h and k, x minus h quantity squared plus y minus k quantity squared is r squared. And of course, this is the extended power rule. So we are going to differentiate both sides, and we're going to go with implicit differentiation. And that means if I differentiate x squared, I get 2x. But what about y squared? Remember, it's g of x to the power of n. Therefore, the derivative of y to the power of n is n y to the power of n minus 1 y prime. Look at the extended power rule. Replace the g of x with y. That's exactly what we get. Therefore, x squared is 2x. Y squared is 2y prime. Any number, including 25, is 0. Since we want to solve for y prime, we are going to move 2x and make a negative on the right side, and Divide both sides by 2y, and y prime becomes negative x over y. Find an equation of a tangent line to the circle at the given point is 3, 4. So basically, those are the pairs, 3 and 4. You have to find the slope. So when we plug in, we get the slope of negative 3/4. Y minus y1 equals m times x minus x of 1. That means y minus 4 equals negative 3/4 times x minus 3. So we're using the point slope, and this is negative 3/4 x plus 9 over 4, and negative 4 moves, comes positive 4, or 16 over 4. Therefore, y equals negative 3/4 x plus 25 over 4 is the equation of a tangent line at 3, 4. This is an example that you definitely don't want to solve for y. We want to find dy dx of y prime. Obviously, x cubed plus y cubed equals 6xy. We're going to start with x cubed and write 3x squared. Y cubed, as I mentioned, just follow the fact that it's y to the power of n gives you n y to the power of n minus 1 y prime. So 3y squared y prime or dy dx. Now, the right side is a product of 6x and y. So you have put a raised dot in between, and I call it fg, and I'm going to use the product rule. F prime is 6 times g, which is y, plus g prime is just y prime or dy dx. Since we use dy dx here, we're going to write dy dx times 6x. And I'm going to box this because this is the only calculus step. Now we use algebra to finish the job. To do so, we are going to move things around. This moves this way and becomes minus 6x dy dx. This moves to the right, becomes minus 3x squared. On the left side, we are interested in factoring dy dx. However, there's a common factor of 3 as well. The right side, there's a common factor of 3 as well. So we're going to factor both sides. And before moving anything, just drop the common factor of 3. You're dividing by 3 in essence. And dy dx is the right side divided by y squared minus 2x. Dy dx is 2y minus x squared over y squared minus 2x. We're going to continue with implicit differentiation. In this case, 2x plus y to the power 4 is x minus 2y. And we start, of course, with the left side. So we follow the extended power rule 4 times 2x plus y cubed. Now times the derivative of the inside. The derivative of 2x is simply 2, and y is either y prime or dy dx, makes no difference. And we move to the right side. The derivative of x is 1 minus 2. Because we used y prime here, we're going to go with y prime. All right, let's distribute because we want to get to y prime. So multiply this one by 2, you get 8 times 2x plus y cubed, and then multiplied by y prime, you get 4 times the parentheses cubed y prime. The right side remains unchanged. Again, this is one way to do it. We want to get to y prime, and so we are going to move this one to the right and put a negative in front of it. Move this one to the left and make it plus 2y prime. Now, what are we solving for? Y prime. On the left side, all we have to do, factor the y prime out. We end up with y prime times this plus 2. This one is 4 times 2x plus y quantity cubed plus 2. And the right-hand side doesn't change, everybody. So what is y prime or dy dx is the right-hand side divided by the brackets. In other words, dy dx or y prime is 1 minus 8 times 2x plus y quantity cubed over 4 times 2x plus y cubed plus 2. So that's pretty straightforward. Use implicit differentiation to find dy dx. Sine y plus 2x cubed y squared equals 6. All right, so sine derivative is cosine. Cosine of what? The same argument, y, and then the chain rule says times the derivative of that, which is just y prime or dy dx. The derivative of sine of gx is cosine of gx times g prime. So that's what we have here. Now, to do the next term, we have to put a raised dot in between because it's a product rule, and f times g, we use that. F prime g plus g prime f. F prime is 6x squared times g, which is y squared, plus g prime is 2y y prime or 2y dy dx times f, which is 2x cubed, and the right side is some number, doesn't matter, 6 or anything else, is 0 when you differentiate. And this is the end of the story as far as differentiation is concerned, and of course we are going to use our techniques to finish the job. All right, so what do we have here? These two are very straightforward. These two, we want to combine them into 4x cubed y dy dx. So these two, they don't change. So we repeat this 6x squared y squared. 2 times 2, 4x cubed y dy dx. Because we want to solve for dy dx, we're going to move 6x squared y squared to the right. And on the left side, so that becomes negative. On the left side, if I take the dy dx out, it's cosine y plus 4x cubed y. And obviously, dy dx is the right side divided by parentheses. So dy dx becomes the right side minus 6x squared y squared over cosine y plus 4x cubed y. So pretty straightforward, everybody. Find an equation of a tangent line, given the function, given a pair, and in order to come up with the equation of a tangent line, we need two things. We need a pair x comma y, we have it. We need to find the slope. To do so, we have to differentiate. To differentiate, we are going to go with implicit differentiation in this case. And therefore, we start with this by putting a raised dot in between, and we are going to start with the first one and say, this one is f times g, and then this one is f times g. Each one use a product rule. So for this one, f prime is 1 times g is e to the power of y plus g prime. Now, e to the power of y is e to the power of y itself times y prime by the chain rule. Think of it as e to the power of g of x times g prime of x. And times f, which is x. So we're done with this. Now we're going to move on to this one and use a product rule. So we need y prime, or since we use y prime here, we're going to go with y prime instead of dy dx. So y prime times g e to the power of x plus, now g prime e to the power of x is itself times f, which is y. And of course, the right side is some number, 1. The result is 0. We're done with this. You have two choices. You can plug in just the way it is, and what remains is y prime evaluated at the pair, and that's fine. But let's solve for y prime. It's really a good practice to do so. We are going to keep these two and factor the y prime out. So we get e to the power of y times x plus e to the power of x. We're going to move this. This is e to the power of y becomes minus e to the power of y. And we're going to move this. This is e to the power of x times y becomes minus e to the power of x times y. So both of them take a negative sign as they move to the right side. So this part, we factor the y prime. Let me just erase my word. So y prime comes out. E to the power of y times x plus e to the power of x. These two, they move to the right, and both of them take a negative sign. So y prime is the right side divided by the coefficient of y prime. This one we have done the factoring. This is what we get. And so what is the slope? Plug in. So we're going to say m is y prime such that x is 0, y is 1. In other words, evaluated. So we are going to replace the y with 1, x with 0, and e to the power of 0 is 1, and this thing, because it's times 0, it's 0. So the numerator is e plus 1, the denominator is 1, and we have a negative sign in front, and we're going to say simply minus e minus 1. Now, when we go back to this pair, this is the y-intercept. Therefore, b equals 1. So using y equals mx plus b, we're going to put this in front of x and then add 1. And this is an exact answer. Y is parentheses minus e minus 1 times x plus 1. So it's pretty straightforward. I hope everybody's okay with that. Find dy dt for the equation for x plus 3y to the power 4 equals x squared, where dx dt is 10, x is 4, y equals minus 2. The moment you see dy dt, you should recognize the independent variable is no longer x, it's t. which means the derivative of x is no longer 1. So the derivative of x is dx dt. Okay, so we are going to differentiate this. Starting with 4x, we get 4 dx dt. 3y to the power of 4, we follow the extended power rule on y. Y is the same as g of x. So 4 times 3, 12y cubed dy dt. And then the right side is just 2x dx dt. Now, there are two ways to do that because they want us to evaluate. I'm going to evaluate it first. Just plug in. That means 4 times dx dt is 10 plus 12. Y is negative 2 cubed. Dy dt is missing. 2 times x is 4 and dx dt is 10. So this is 40. This is 80. Minus 8 times 12 is minus 96. We are going to subtract the 40. So we get 40 on the right. We're going to divide by negative 96. And we get negative 5 over 12. Divided is negative 5 over 12 is the final answer. However, and we are done. We're fine. However, what if we wanted to, right here, we wanted to solve for dy dt? And if we want to do that, then we have to move this one and make it negative on the right side. And divide the right side by 12y cubed. And notice on the right side, there is a common factor of 2 dx dt. So we're going to write that way. Therefore, I can get rid of the 2 here and change this to 6. This is the final answer. Dy dt is dx dt times x minus 2 over 6y cubed. And if I plug in, I will get the same answer. Now, did I have to do this? No, but in many cases, they want you to come up with a dy dt first. So that's a good practice there. Find dx dt. The equation is 3x plus y e to the power of x equals 20, and dy dt is negative 8, x is 0, y equals negative 1. Needless to say, t is the independent variable. We are going to start differentiating. We get 3 dx dt. And we put a raised dot in between. That means fg, use the product rule, f prime g plus g prime f. So this is dy dt times e to the power of x plus e to the power of x is e to the power of x dx dt. And that's the key. You want to be very careful. E to the power of x is not just e to the power of x times dx dt because t is the independent variable, then times y. And the right side is a number, ends up being 0. We're done here. Again, we're going to do 2 ways for just practice. First, we're going to plug in. So 3 times dx dt plus dy dt, replace it with negative 8, e to the power of 0, again, e to the power of 0, and dx dt times y, which is negative 1. So plug in and evaluate. When we plug in, of course, e to the power of 0 is 1. We get 3 dx dt minus 8 minus dx dt equal to 0, and is to add up to 2 dx dt. Negative 8 becomes positive 8 on the right, divided by 2, and we get 4. Very straightforward, everybody. Or we're going to go back to the top. We want to solve for dx dt, which means this will have to move to the right, and of course, takes a negative sign. Since we are solving for dx dt, we factor the dx dt on the left side out. We get 3 plus y e to the power of x. And the right side doesn't change. All you have to do, divide the right by the parentheses 3 plus y e to the power of x, and that's dx dt. And if you plug in, of course, you will get the same number here. So again, for practice, it's a good, I mean, this is elementary algebra, but it's a good idea to do so. Okay. Again, t is the independent variable because we're looking for dy dt, 5x plus y to the power 4 minus x equals 6, dx dt, x and y are given. So we start with differentiation. Differentiation, this is going to use the extended power rule, so we're going to start with 4. Then same thing, cubed. Now, times the derivative of the inside, we are looking at g prime of x at this point. So 5 dx dt plus dy dt. Now, minus x gives us minus dx dt, and any number including 6 gives us 0. I'm going to plug in, and I'm not going to go with the second method to solve for dy dt, just plug in. So plug in all the values that you have. In other words, 4 times 5x, 5 times 2, plus y, that means plus negative 9 or simply minus 9, cube it 5 times dx dt plus, that means 5 times 3 plus dy dt minus dx dt, which is 3, and it's equal to 0. So plug in. So when we plug in, this is 10. 10 minus 9 is 1. 1 cubed remains as 1. 5 times 3 is 15. This is what we get. Distribute number 4, and we get 60 plus 4 dy dt. Numbers add up to 57. So 57 moves, and it becomes negative on the right side. Dy dt becomes negative 57 over 4 as the final answer. So be very careful. What is your independent variable? Okay. So having said that, how do we differentiate this? Well, we are going to use the chain rule, but bear in mind, anytime the numerator is a number, you don't have to use the quotient rule. Again, if you have to use a quotient rule, try to avoid it. You make it more difficult, and vice versa. So this is the same thing to the power of negative 4 at top. I'm looking at negative exponential rules, everybody. Now I'm going to use the extended power rule, and I'm going to say minus 4. So y prime is minus 4. Parentheses to the power of minus 5, because minus 4 minus 1 is minus 5. And then times the derivative of the inside by the chain rule, 14x minus 1. And I hope you see that basically you have a fraction bar, negative 4 and 14x minus 1 remain at top. This goes to the bottom and takes a positive 5 as the exponent. With that. H of x is cosine of 5t over 5t. Well, we're going to write it as f over g. And we are going to use the quotient rule. So we start with f prime. So the derivative of h prime is f prime, which is now cosine of 5t becomes negative sine 5t times 5 times g 5t minus g prime 5 times f cosine of 5t over g squared. Just square this, 25t squared, put it at the bottom, and we're done with calculus. To simplify, let's take a common factor. From the numerator, we notice negative is in common, so is 5. So if I take the negative out as well as 5, this gives me 5t times sine 5t, and this just gives me plus cosine 5t. Okay, so that's the proper factoring. And this negative 5 just becomes negative. This 25 becomes 5. Now you can put the negative in front of a fraction bar and say what is left, 5t plus sine 5t plus cosine 5t in the numerator, 5t squared at the bottom. And this is the final answer, everybody.